my classroom. Discuss chemical process calculations. We have been discussing about material balance in unit operations, and we are going to discuss about what is dryer. Uh, Drying refers to the removal of relatively small amounts of moisture from a substance which is generally a solid. However, in some specific cases, it includes the removal of moisture from liquids and gases as well. Drying is generally a final step in the production process, and the product from the dryer is often sent for final packaging. So this is the final unit operation in most of the industries, where it is just before packing. Whatever excess moisture that is present in the product has to be removed. So once the moisture is removed, the product is usually sent for packing. So usually this is the final stages of any industrial process. We have this drying operation taking place, and it is often an important necessary step in various industrial operations, particularly chemical industries. So not only just chemical industries, there are metallurgical industries, construction and material making industries, sand industries, slag making industries, soap and cement industries, coal industries and mineral industries. And these are some of the industrial examples. The giant sizes of the dryer is not just like our home hair dryer. You can see the size here. So they are mainly made up of dryer drum, a front roll, a back roll, a gear. So there will be rotating parts. So these are some of the drying units that are usually present in the cement industry. This one, the lower one, the upper two are in cement industries. The lower one is from a liquid also. As I said, mostly it will be removal of moisture from solids, but there are cases where from liquid also we will be removing moisture. So the below two images are examples for such case. So you can see that liquid constituents and dry constituent will be initially mixed separately. So after that, that will be combined together to dry the products. This is a spray dryer where the liquid is sprayed using nozzles. So they are micro droplets are sprayed in a chamber, cylindrical chamber, and where you will send in hot air or something to take away the moisture present in it. The vaporized moisture will be removed. So the dry solid materials will be collected at the bottom. So there are cases where there will be complete removal of moisture, like milk powder case. Right hand side you can see the case where you final product is totally a milk powder without any moisture present in it. Okay, so that way spray dryers are also widely used in chemical industries. There are basically three methods of drying which is widely used even today. So sun drying, one of the traditional method in which we dry the materials in natural sun. For example, in seashores you might have seen how the salt is being separated out from brine solutions. They collect, water is kept in different patches, and in sunlight, natural sunlight, water is allowed to evaporate. On the weather conditions, that drying will take its own course. Means drying, it will take its own time. So once the water is totally evaporated, the salt is collected and packed, right? So that is sun drying, example for sun drying. Other way of doing drying is hot air drying, in which the materials are exposed to a blast of hot air. So we have to, that means we collect through a blower, hot air, natural atmospheric air will be collected. So it will be allowed to pass through some heating material. So the air gets heated. So that hot air will be coming in contact with the material, which needs to be moisture has to be removed from it. So that is one way of doing drying, hot air drying. There is another drying called freeze drying, where you minimize the pressure, that is you keep the material in the vacuum chamber so that the water gets frozen out. So that is one way of drying. Usually in meat industries this freeze drying is being followed. The fundamental nature of all the drying process is basically the removal of volatile substance such as moisture, mainly moisture, okay, from the mixture to get a solid product. So we will initially with the moisture content will be more, finally the moisture content will be less, or sometimes it may be final product may be free from any moisture also, right? So that is the thing. So we should understand what is drying. Once we know this drying, in this particular course we are going to do only material balance for drying operations, but you are going to learn the mechanism, principles, design calculations of these dryers in master answer 2 course. Okay, so in this course we are going to focus on dryer. Okay, get ready. So in drying operation, what is the stream that is entering the system? Entering a dryer, wet solids. Wet solids will enter the system. So that wet solid comprises of dry solids. Wet solid consists of moisture and dry solids. So let me say if there is 100 kg entering the system, if I say 60% solids, then 40% is moisture. So that will be the composition of a wet solid. It will consist of 60, let me say 60% solids and 40% moisture. Then that is the composition for feed stream. And there will be a product in this. In dryer, typically what we are doing, we are removing moisture. So there will be water being evaporated, will be one outlet stream. Okay, output. Another output is these wet solids will get dried, so that way the solids with less moisture content is our product stream. So you have one feed stream, one product stream, and one evaporated water. So there is one input, two outputs. Similarly, if you make individual material balance, whatever is the amount of dry solids that is present in the feed, that will be present in the product stream. So that will make our individual material balance for dry solids. So that will easy help us to find out the product value, what is the flow rate of product. Okay, sometimes even it will be said that this much percentage of water is being removed from the feed. So that way also another way of determining what is the amount of water evaporated. So for all this, first we should make a block diagram. Let us draw a block diagram.
Here. So we will have a feed section. Feed will be mostly solids. So there can be liquid also. Means whatever is not the moisture, feed containing certain amount of moisture. Okay. So let X of be this one. X of be the mass fraction of solids. So the feed containing this is feed is generally called wet solid. Okay. It's called wet solid. Wet solid consists of dry solids and moisture content, whatever is the content of moisture. Okay. So what happens? We will be evaporating water. So like can say E is the water evaporator. And then we have final product where we get dried product. Okay. So we have one input F and we have two output, one D and E. Okay. E and D are the product, and what solid is not escaping along with this water evaporated. So that way, whatever is the dry solid amount that will be present in the dried product also. Let the XD be the mass fraction of solids in it in the product. Okay, so then what is the overall material balance? Overall material balance is F equal to E plus D, where E is the amount of water evaporator. Okay, D is the dried product, F is the feed, all are in kg mass. Okay, mass balance. It can be kg per hour or kg per second or kg per day. Okay, whatever depending upon the situation. General, any flow rate we will say kg per hour. Okay, so what is the individual material balance for solids? Means individual material balance for solids. Individual material balance for solid is XF into F is equal to XD into D, right? XF into F equal to XD. Whatever, what is the meaning here? Whatever is the amount of solid that is present in the feed will be present in the dried product. Because there is no loss. We are not considering any loss of solids in the system. Okay, in ideal case, we are considering that whatever amount of solid that is entering is leaving, right? So that way, XF into F equal to XD into D is the individual material balance for dry solid. Okay. So remember, if there is, and also here what is the assumption? Here there is no loss along with the water as well as in any other form. That's why we have overall material balance 1 and we have individual material balance 2. And let me say this contains some amount of water. Okay, so feed contains certain amount of water, and the product what certain amount of water is evaporated. So we should able to determine percentage removal of moisture. Percentage removal of moisture can be determined. Whatever is the E, then whatever is the amount, let the amount of water here is H. E by H is the E by H is the into 100. So that way we can report what is the percentage removal of moisture from the feed. Okay, so that E is the amount of water produced, H is the amount of water present in the system. So we are going to get it once XF is known, F is known, we can find out what is the amount of water, right? It is XF means 1 minus XF. 1 minus XF into F is this one. Or generally for drying problem, moisture only will be given. So moisture will be given like initially 50% moisture is there, and if feed is 1000, we are going to get 50% is 500 kg. So that will be the denominator value. Okay. So the numerator is amount of water to be removed. It can be determined in two ways. Either the percentage of solid in the feed and D will be given, or it may be given that certain percentage of from the feed 80% of moisture is removed, or X percentage of moisture is removed, like that. So in that case, whatever is the amount, from this amount that X percentage of water is removed. So E can be determined to find what is D, or it can be given what is the XD moisture present in dried product can be given. Moisture in product will be given, so we will be able to determine. So moisture is known means whatever is the remaining amount of solid we can find out. Okay, so remaining is solid, so the same amount of solid is going to be present. From the D can be determined. From D you can determine E. So first step is either one way is to determine the D and then get E value, or if percentage of water removal is given, that way we will we will report. First to find the E and then find out what is the D. Okay, so that both ways we can solve the problem. And finally we may have to determine the amount of water removed from the system. Okay, this is for single stage one. Okay. Is it okay? Shall we move on to solve the problem?
Yes, sir.
Okay. This is one case. There may be a multiple effect dryer also. Okay. So what is in the case? I can. Sorry. So we can have two-stage dryer. Okay, so if it is a two-stage dryer, you are going to have a feed stream. Okay, so whatever dryer 1, let me say dryer 1 and dryer 2. So what happened? This is dryer 1, dryer 2. So certain amount of water is evaporated here, right? So E1, and here the dried product is D1. So you have F. So what is the overall material balance for dryer 1? So you can write F equal to D1 plus E1. Okay, so this is overall material balance for dryer 1, right? Similarly, what is the individual material balance for solids? That it contains X of solids, that it contains XD1 solids, that is mass fraction of solids, XF. It can be any percentage. Okay, so if it is given in percentage, we will write in fraction. So what is the individual material balance? XF into F is equal to XD1 into D1. So this is overall material balance. This is individual material balance for solids. Okay. It can be for liquid also, that's not the case, but generally we are referring to whatever is not the moisture, that is our material, substance, individual material balance for substance, you can say. So here the dryer, so again we are going to get some dried product out of this system. So let it be D2. This is the dried product, right? D2 is the dried product. Let XD2 is the mass fraction of solids. Okay, and it also will have a certain moisture. Okay, and it will have some water evaporated E2. So here we are having D2 E2. So what is the overall material balance for dryer 2? For dryer 2, D1 is the feed. Okay, remember we are not having F here because it is continuous. Some people can use F1 also. See, these notations, as we are comfortable, we can use anything. Okay, you can use F0, F1 here as D, simply 1D. But here I am just for continuation of earlier single unit system, I am just using the same with D1 E1. Okay, so D1 is the input, is equal to output. What are the overall output? D2 kg of dried product plus E2 kg of water. Remember, E1 and E2 are water evaporated. So got it? I repeat. So we have a feed stream F kg. It can be kg per hour or tons per hour. It depends upon whatever is the issue, given data. Okay. F kg per hour of feed is entering. Let it have a solids of X of percentage. So let XF is the mass fraction of solids. Remaining is moisture. Okay. So in the dryer one, a certain amount of water is evaporated, moisture is removed. How moisture usually removed is, usually we supply air. Dry air will be supplied. Okay. Dry air will be supplied, and while leaving, it will carry some amount of moisture along with it. Okay. So that way, that water will be evaporated. So E1 is the amount of moisture removed. D1 is the moisture removed in dryer one. That the XD1 is the function. So we should be able to write individual material balance for these solids. XD1 is the solid percentage in the feed. Okay. So what is the individual balance? XD1 into D1 is equal to XD2 into D2. Okay. These more fractions. These are mass fractions of here the product that is leaving the stream on. XD2 is the mass fraction of solid in the stream that is leaving as the dried product from the dryer 2. Okay. So these 4 material balance we will be using if you want to solve numericals in this case. Okay. So these are the various cases. And again, what is the percentage water removed? Percentage water removed. Percentage water removal is here for in the dryer one. In dryer one, what is the percentage water removal? In percentage water removal in dryer 2, we should be able to write. Okay. Percentage water removal in dryer 2 is whatever is the amount of E2 divided by amount of water in D1. Here what is the thing? E1 divided by amount of water in F. Okay. So that way we will find the percentage water removal from dryer 1, percentage water removal from dryer 2. Okay. Yeah. Take down this problem. We will do this problem. I'll type here. Actually, we should be able to type. Yes. Take down 2000 kg of wet solids containing 70% solids by weight are fed to a spray dryer where it is dried by hot air. The product finally obtained has 1% moisture. Calculate the amount of water removed from wet solids and calculate the amount of product obtained. We try to solve this problem. First, draw a block diagram. Hope all of you are having notebook. Please practice now itself. Then only towards the end exam, it will not be overburden for you.
Shows question.
Yeah, I'm going to the question. (2,000 kg of wet solids containing now it is visible for you. 2,000 kg of wet solids containing 70% solids by weight are fed to a spread dryer where it is dried by hot air. The product obtained finally has 1% moisture by weight. Calculate the amount of water removed from wet solids and calculate the amount of product obtained. What we have to do? Here basis is given 2000 kg, right? So we have a block diagram. We have a dryer. Feed is containing F is equal to 2000. It is containing 70% solids, which means that 30% is moisture, right? And we have D, which contains, it is given that 1% moisture is there. So it is 99% solids, right? So how we get 99% solid? It is mentioned that the product obtained has 1% moisture by weight. So that way we have 99% solids, 1% moisture. Okay. So now it is easy for us to find out D and E. Okay. What is the overall material balance? Overall material balance is F equal to D plus E. So E is equal to F minus D. This is 1000 minus D. Equation number 1. So what is individual material balance?
Sir, it is 2000.
Oh, sorry. F is 2000. Okay. So F is given 2000 minus D. Let it be equation number 1. So individual material balance, you can do XF into F is equal to XT into D. XF is 70%, right? 70 by 100. Some people you can easily substitute like this. 70 by 100 into 2000 is equal to 99 by 100 into D. This will give us D value. So what is the value? Then substitute 2 in 1. We get E value equal to 2000 minus the value. This is a simple straightforward problem. I hope you prepared this for mid also. What is the value?
1414.14.
Okay. So we can check it. 1414.14 kg. So what is E value? 2000 minus this.
585.86.
585.86 kg. So you can write the answer in sentence. What is the question? Calculate the amount of water removed from the wet solids and calculate the amount of product obtained. So you can write it in sentence the same way. The amount of water removed from wet solids is 585.86 kg and the amount of product obtained is 1414.14 kg. Okay. The amount of water removed from wet solids is 585.9 kg. The amount of product obtained is 1414.1. That is our answer. Okay. Okay. All of you got the answer? Hopefully. Take the next one. 1000 kg of wet solids are fed to a dryer and moisture is reduced from 60% to 20% by 8. Find the mass of water removed and percentage moisture removal. Simple straightforward problem. You should be able to complete. F, you have F, you have E, and we have D. Here 20% moisture, here 60% is moisture. Can alternatively use moisture or water, that's what the issue. Okay. So here you have 40% solids, here we have 80% solids. What is the unit? Here it is dryer. So what is the overall material balance? F equal to D plus E. and individual material balance is XF into F equal to XT into D for solids. Individual material balance for solids, overall material balance. That is equation 1 and 2. You get E equal to F is given, right? 1000 kg per hour. So F is given 1000 kg per kg. We have 1000 minus D. So XF is given 40%. So 40 by 100 into feed is 1000 equal to XD is 80%. What is the value?
500.
500. D value is 500.
Yes, sir.
D is 500. So you have E value is 1000 minus 500, which is 500. Okay, so we have D and D value same. So what is asked? The percentage moisture removal is asked. Okay, so how to find percentage? Amount of moisture in the feed is 60 by 100. 60. What is the amount of moisture in the feed? Amount of moisture in feed is equal to 60% of 1000, right? That is 600 kg. So you have water in the present in the feed is 600 kg. Okay, which I also used to write with capital H, right? Whatever is the amount of water in the feed is 600 kg and E is 500. So you can report what is the percentage removal of moisture. Percentage removal of moisture is equal to 500 kg, that is the E value, okay, by this amount of moisture in the feed, okay, which is 600 kg into 100, right? How much?
83.33.
How much?
83.33.
3.33.
Yeah, very good. So you have 83.3% removal. So that is the answer, right? So you can write it in sentence. The mass of water removed is 500 kg and percentage moisture removal is 83.3%. Okay. Answer. Please write the answer. The mass of water removed is 500 kg and percentage moisture removal is 83.3%. Okay. Okay, please write it in sentence. The next one, Take down. Spray dryer is fed with 1000 kg of wet nitroaniline containing 10% moisture. The dried product containing 99.5% nitroaniline and rest water. Find the percentage removal of moisture. A spray dryer is fed with 1000 kg of wet nitroaniline containing 10% moisture. The dried product containing 99.5% nitroaniline and the rest is moisture. Find the percentage removal of moisture. So draw a diagram. We have F. So what is the overall material balance? F equal to D plus E, and you have XF into F equal to XD into D. That is 90% of feed. Feed is given 1000, right? F is 1000. Equal to what is the D value?
904.52.
Good. 904.52. Okay. So what is the thing? Next you have to substitute in equation. Let it be 2 in 1 gives E equal to F minus D, which is 1000 minus 904.52. How much? 95.5 kg. Okay, so now main important thing is you have to determine the percentage moisture removal. Percentage moisture removal is E by amount of moisture present in this one. Here, what is the moisture? Amount of water in feed? Amount of water in feed is equal to 10% of F, right? XF is 90% means remaining is 10%, right? So 10% of 1000, this is 100. Okay, so here amount of water in the feed is 100. So 95.5 by 100 into 100. How much? Same percentage, right? 95.5% is the moisture removal. Percentage moisture. Question is find the percentage removal of moisture. So you can write the percentage moisture removal is 95%. So that is our answer. Okay. So these are some simple problems. We'll move on to double stage ones. Take down with solids. It's very small font size. Okay, wet solids containing 20% water is sent through a dryer in which with solids containing 20% water is sent through a dryer in which 80% water is removed based on 100 kg of feed. Calculate A. Mass fraction of dry solids in wet solids that leaving the dryer. B is weight ratio of water removed to wet solids leaving the dryer. Third part is if 1000 kg per day of wet solids is fed to a dryer, find the additional water to be removed to dry the solids completely. Wet solid containing 20% water is sent through a dryer in which 80% water is removed based on 100 kg of feed. Calculate mass fraction of dry solids in wet solids that leaving the stream dryer. So this is a fraction ratio we have to determine for the given feed, 100 kg per day feed. Okay. So C part we will do finally. First we will do first two parts. Let's solve it. Am I audible?
Yes, sir.
Okay. So please solve this. So what we have to do? this. We have a feed 100 kg. See, for A and B part, feed is 100 kg. For C part, we are going to have 1000 kg. Okay, so feed is 100 kg. It contains solids, moisture. Moisture is given 20%, which means solids is 80%. And we have D, where it is given 80% of water is removed. 80% of moisture is removed. So in this case, we are going to first get E, then only we are going to get D value. Okay. So we have F equal to D plus E. So what is the amount of water in feed? Amount of water in feed is equal to
20 kg.
Yeah, 20% of 100, which is 20 kg. The feed contains 20 kg of moisture, and it is said that 80% is removed, right? So E is equal to 80% of 20, that is 80 by 100 into 20. How much?
16.
16, right? Okay. So what is D then? D equal to F minus E.
24.
E got 16, F is 100, E is 16. So we get D equal to 84 kg, right? So now go to the second part of the question. So what is the XD value? Whatever is the amount of solid that is present is going to be present here also. So what is this? 80 kg. Dry solid is 80 kg. So D will contain two things. What are they? Whatever is the amount of dry solid here, it is 80 kg, right? 80 kg of this plus 4 kg of water, because out of 20 kg water, 16 kg is removed. The remaining 4 kg will be there. So 80 kg will be the solid, 4 kg will be water. Total DY is 84. Now try to answer the question. What is the mass fraction of dry solids in wet solids?
80 by 84.
Yeah. So that way you will get the answer for first part also. So answer for A part is 80 kg divided by 85 kg. So whatever is the value, you get
95.
0.95.
5.
This is the answer for A case. Similarly, B part answer is 16 by amount present
84.
84, right? 16 kg divided by 84 kg. Fraction. Say if it is asked in percentage, we should be able to multiply by 100 and say 95%. Okay. Here it is 16 kg. That is weight ratio of water removed to wet solids. So your wet solid is D. D is nothing but our wet solid. Okay. Dry solid is 80. Okay. 16 by 84, which is 0.19.
19.
Very good. Now go to the third part. Little tricky. So what is the additional water that has to be removed if the feed is changed to 1000 kg? Remember, already we are removing 16 kg. If it is 100. Okay. So what is the amount of moisture to be removed if it is 1000 kg per day is the feed? Okay. That means additionally we are going to supply 900 kg. Okay. So that is 16 plus 9 times 16. That is shortcut. Let us do it procedure wise. What is the amount of moisture to be removed? Okay. So if F equal to 1000, then amount of water is equal to 20%. Moisture is 20%. So amount of water is 20 by 20 20% of this is 200, right? Currently 16 kg of moisture is removed. So additionally, how much moisture is to be removed? So remember 80% of this thing, right? Now question is complete drying. You can see the word. Find the additional water to be removed to dry the solids completely. If we say completely, what is the what?
All 200 should be removed.
Find the additional water to be removed. So that means D is going to be not having any moisture. So whatever moisture is present in the feed, that should become E. Okay. So we have E becoming 200. Understood? Now answer the question. Find the additional water to be removed to dry the solids completely.
36 kg, sir.
36.
174. 184.
184.
Very good. 200 minus 16, which is 184 kg. This is for complete drying. This is the additional amount of moisture, because right now when the feed is 100, we are removing 16. What is the amount of additional water to be removed when we increase the feed rate from 100 to 1000? We are calculating additionally 184 water.
It shouldn't be 200. So
What?
sir, it should be 20% of 900. No.
No, we are not calculating. Say that is the thing. How you are calculating, you decide. I consider F equal to 100 here. When you say like that, you have to consider F equal to for 900. What is the amount of moisture? Right? 20% of 900. That will be a direct answer. Additionally, how much moisture is removed? You are going to get around 184 here directly. Right? Check it. 10% means 90. 180 you will get, right? So for this, we are going to additionally remove 180 something. Is it correct? Okay, we are not calculating 900 alone. We are calculating for total. Out of the total, we are considering removing the 16, subtracting the 16 to get what is the answer. Okay. So the answer for the C part is it correct? Any other answers? Yes.
Sir, in that question we are subtracting 16, but 16 is the moisture removed for 80 kgs, no sir? Like for 100 kgs.
Yeah, 100 kg. Yes.
So if we take 1000 kg per feed per day, then it is not 16, no sir. It will become 116, no sir.
So this question we can imagine in this way. First we sent 100 kg, then we mixed that 100 kg to initial feed, and now we want to remove 100% liquid. Then we get 184, right?
Yeah, actually initially it is 100 kg per day. Finally it is 1000 kg per day.
Yes, sir, but then evaporate becomes for 100 kg, if it is 16 kg, then for 1000 kg it will become 160 kg, no sir. 80% of that one.
No. First case is given like that, but in second case it is given like complete removal of moisture.
But the dryer efficiency remains same, no sir. It is taking 80% of water. Means in the second case also it will take 80% of water only, no sir.
No, that is not mentioned. No, you read the C part is independent of first two parts. That's why I told first two parts is independent. C part is this is the way we ask in exam. These are mainly for exam purpose. Third case is totally different. It is not mentioned 80% is removed. You see, read the C part. If 1000 kg per day of wet solid is fed to a dryer, is it mentioned 80% removal or 90% removal? Nothing. Find the additional water to be removed to dry the solids completely. Here the keyword is completely. So here complete removal of moisture.
Okay, sir.
Okay, you understand the word completely. Is it the meaning 80% removal? No, no.
No, sir.
So that way we have to careful. This C part is additional part, which is independent of A and B. Here we should not consider the cases whatever is given for A and B. Only thing is the additional water is mentioned. That's why we are considering for 100 kg case. Okay, this 16 kg we considered.
Sir, in the question given only, they said 80% of water is removed, no, sir. The main question.
Yeah, yeah.
So, when removing A and B, if we take only C, then in that case also we should take 80% of water is removed. No, sir.
%80% water is removed, but then we will miss the word completely, no? If it is not given completely, then we will follow what you are saying. 80% of water is removed.
Okay, sir, but okay, sir, if we take like that, if 1000 kg is given, then 80% means something, we get 160, so 160 is removed. Then additional water to be removed, then it will become 40, no, sir. Actually, 200 should be removed, but in the case of this dryer, 160 is being removed. So the remaining we need to remove is 40. Like that shouldn't be considered, sir.
No, no, it is like relative comparison. See, even for A, B cases, here the comparison is find the additional water to be removed. Means whatever was the previous case, it is only numerical value importance to us. Numerically, how much is the additional water we are going to remove from the previous case to this case. We are relating the answers of the previous case to this case. What
But
is
in
the
the previous
additional?
case, it is for 100 kg, no, sir. How can you relate same thing for different feed given?
No, no. Here different case is different, but here we are asked you to relate the values. Forget about what is the operating condition. We have final water to be removed in first case and this case. Okay. In first case, water is 16 kg removed. In second case, it is 200 kg. We are asked.
So I think, hello. I
Yeah.
think here 16 kg is already removed, and we need to remove some more thing, some more part of water, sir. I think. Is it, sir?
Actually, it is only relative term, just like how we are asked to find out what is the ratio here, 80
Yeah,
by
and
84, 16 by 84.
sir, add
Hello.
another.
Hello?
Yes, sir. I'm saying that you had been sending 1000 kg of feed for the C part.
Yeah.
In the first part, you had sent 100 kg.
Yes.
So you removed 80%, and the feed contains 20% of water. So 20 kg into 0.8. So 16 kg
Yeah.
you removed in the first part.
Yes.
So for 100 kg you have solved. For 900 kg you have to solve it again, and that is the additional that we have to remove, I think.
No, no, that is not the case. Because here it is complete removal. Here the case is complete removal. First case is 80%. Forget it. It's like your first attempt you got 20 marks. In second attempt you got 90 marks. Question is what is the additional mark you obtained in the second attempt, right? So we forget about what is the individual question in the cases, right? We are relating the terms. You say if you are confused, you can simply say 200 kg for complete removal. 200 kg of water is evaporated. In the first case operation, it was 16 kg. So additionally, the value with respect to amount of water removed is the value numerical value difference only asked. There is nothing technical part is asked, right? It is only numerically how much is the value change. Initially it was 16, now it is 200. So what is the increase in the evaporation rate between the first operation and second operation? Okay, so first operation is 80% removal, second operation is 100% removal. So the amount removed completely, that is where it is tricky. Question is tricky here. Complete removal, additional water removed. If you simply ask what is the water removed, it is straightforward 200 is the answer. Okay. So these are only to confuse the things. Understanding of the word, what is additional, what is the meaning of complete removal. Okay. We'll do one more short numerical and stop here. This is a double two-stage one. take down. A dryer system handles 1000 kg per day of wet solids containing 50% moisture and 50% solids are fed to dryer 1. From dryer 1, the product comes out with 20% moisture. This is admitted to a second dryer, that is dryer 2. A dryer system handles 1000 kg per day of wet solids. Wet solid containing 50% moisture and 50% solids are fed to a dryer 1. From dryer 1, the product comes out with 20% moisture. This is admitted to a second dryer, from which the product this is admitted to a second dryer 2, from which the product comes out with 2% moisture. Calculate the percentage of moisture removal and find the percentage of moisture removed from each dryer and final weight of product. I think I explained already. Those who joined late. I explained already how to do it. Please solve it yourself. Should I explain? Anybody join late who could not follow what is told in the beginning stage? Please let me know. The percentage calculation you are making mistake.
Sir, hello.
75% and 91%.
What?
75% in the first dryer and 91.8% in
Yeah.
second.
Yeah, correct. So percentage water removal, I will show you again. Maybe material balance you are doing correctly. So as I said, percentage water removal is E1 divided by amount of water in the feed. Okay, amount of water in the feed is 50% of 1000. That is 500 in the denominator here.
Yes. I took
375. Yeah. 375 divided by 500. It should be.
Yes.
Similarly, in the second case, here it is coming out with a certain percentage of moisture. That is 20% of 625. D1 value you get 625. So you get value 125 is the amount of moisture present in D1. So here the denominator will be 125.
Sir, in that form, sir, we have to write last one, that product answer.
Yeah, product answer is correct. Yeah, 5 on 10. No, total all three answer you write. In sentence I want.
Okay, sir.
Final weight percentage of product. As you actually how you type, that way you want to type answer to be submitted. Okay. Final answer is final weight of the product is 510.2 kg. Someone is singing nicely. 510.2 kg is this one. Similarly, percentage water removal in first dryer is 75% and 91.84% respectively. So that will be the answer for this question. So this is what you are supposed to submit in the answer there.
In this lecture, we have seen some numericals on dryers with simple operation, simple drying, where one first case we have seen numericals by whatever is the dried product is this much percentage is the moisture present in the dried product, that is first case. Then we have seen this much percentage of water is removed from the feed stream, that is the second case. Then third case problem we have seen multiple effect dryer, that is two stage dryer numerical we have seen. Okay, next example, in the next class we will solve some more numericals with recycling of the air into the system. Okay, so with recycle we will do some numericals for material balance in unit operations. Thank you for patiently watching this video, and I hope you practice the numericals. Okay, practice only makes us perfect, so please practice the numericals, and if you have any doubts, please feel free to contact me. Thank you for joining my classroom.